Okay, Assalamualaikum and a very good day to everyone. So, welcome back to Mathematics Form 5 KSSM 2021. So, here is our first topic, which is variation. Okay, so this topic has three subtopics. First is direct variation, second is the inverse variation, and the last one is combined variation. Okay, for the first subtopic, direct variation, first we get to know the meaning of direct variation. Okay, so here in the first subtopic we have following standards. So first is to explain the meaning of direct variation. So let's look at a situation here. So you can see a chef needs to decide the amount of ingredients to be used according to the number of servings. So if we increase the amount of ingredients used, so that means we're gonna get more number of servings. Okay, so when the ingredients used increases, so the number of servings increases. If we use less amount of ingredients, so meaning we got to have less number of servings. So that's an example of direct variation. Okay, so here is another example. If you look at mind mobilization 1, the step here is to browse from the internet. So 1 ringgit Malaysia equivalent to how much Singapore dollar, Thailand baht, Japanese yen. Okay, so 1 ringgit, 10 ringgit, 20 ringgit, 30 ringgit. Okay, I have filled in my textbook. Okay, I did on 21st January. Okay, so you got to do it on your own. Okay, please make sure you have this in your notebook. Okay, so you fill in, so you can just browse in the internet. So what you can see actually is when the value of Malaysian ringgit increases, so does the values of Singapore dollar, Thailand baht, and the Japanese yen. Okay, when the value of Malaysian ringgit increases, then the values of the Singapore dollar, the Thailand baht, and the Japanese yen increases as well. Okay, so when the value of Malaysian ringgit decreases, so does the value of the dollars, the baht, and the yen. Okay, so next is to determine the relation between two variables for direct variation. So just now, the definition of direct variation, okay, it's to explain the relation between two variables, such that when a variable increases, then the other variable increases at the same rate. Okay, and vice versa. So we can write as y varies directly as x. Okay, so after this you will see more and more y varies directly as x, k varies directly as l. Okay, and things like that. Okay, so here is another example. Okay, look at the table first. So here in the table we have values of x and the values of y. Okay, next we did y over x and x over y here. Why? So we want to find the constants of proportionality. That's our aim. Okay, because we know when the value of x increases, so you can see x equals to 1, y equals to 2. When x becomes 2, y becomes 4. When x becomes 3, y becomes 6. Okay, so the value is actually double, right? From 2 becomes 4, 4 becomes 8. Okay, so that double thing is actually the y over x. Okay, when you divide the value of y to the value of x, so you can see every time you will get the value of 2. It same goes to when you divide the value of x by y, you will get a kind of constant, but it's a bit different. Okay, it becomes 1 over 2. Okay, so which one do we need to use for us to get the equation? Okay, so I think for you to know is we call that constant y over x as a constant of proportionality, symbols as k. Okay, so example 1. So the question was to express y in terms of x. So how are you going to express y in terms of x? Okay, so we know that when x increases, y increases. Okay, so we say that y is y varies directly as x. Okay, so first step is to write like this. Okay, y varies directly as x, like this. This one we call it variation relation. Next, we change this symbol proportional into equals to k. Okay, so now we have y equals to kx. Okay, we change the symbol is proportional to equals to k. So this one up here, the number 1, we call it variation relation, and the second one we call it equation form. Okay, so from the example just now, we know that y varies directly as x, so we have y equals to kx. So now our job is to find the constant k. Okay, we know that just now our constant is y over x. Okay, so k equals to 2. So finally, when we want to express y in terms of x, we will write y equals to 2x, like this one here. Okay, y equals to 2x. Okay, are you guys good? Okay, shall we go to next example? Okay, here's example 2. Okay, we have the same value. We have 4 values of x and another 4 values of y. Now the value of x, now the value of y becomes increases way too faster than x. Okay, so when x equals to 1, y equals to 2. When x becomes 2, y becomes 8. When x becomes 3, y becomes 18. So do we still call this as direct variation? Can we still say it is a direct variation? Okay, let's look at the value of x squared first. Okay, so when x is 1, the x squared is 1. When x is 2, the x squared is 4. 3, 9, 4, 16. Okay, so now the constant part is not y over x anymore. Okay, it now has become y over x squared. Okay, the y over x squared is now a constant, not the y over x. Okay, so this is how we write it. Okay, y is y varies directly as x squared, so y equals to kx squared. Okay, the graph of y against x squared is a straight line passing through the origin. Oh yeah, something I forgot to tell you just now, so you go back to the previous slide here. So for variation, for direct variation, you will see that you can for graph of direct variation, you will get a straight line graph passing through the origin. It must pass through the origin. Okay, you cannot just simply have a straight line with different y-intercepts other than 0. Okay, so if we look at example 2 just now, the y equals to kx squared, the graph of y against x squared is a straight line passing through the origin. So meaning you would get a straight line graph if you draw a graph of y against x. Okay, so y against x you won't get this kind of graph, okay, because the y values goes up very fast, okay, way faster than the value of x. Okay, next example 5 and 6. So you look into the textbook. Next I want to discuss about example 7 in the textbook. Okay, example 7 is problem solving. So the area of a semicircle varies directly as the square of its diameter, d. It is given that the area of the semicircle is 3.08 cm squared when the diameter is 2.8 cm. And the question asks you to calculate the value of d when L equals to 19.25. Okay, so first from the questions, so we can see that L, the area, varies directly as the square of its diameter. So L let me use black. Okay, L varies directly. Okay, so we do it like this, square of its diameter, so diameter square. Okay, so then we change the symbol into equals to k d squared. Okay, and then we find the value of k. Okay, next to find the value of k by using the first information, 2.8 and 3.08. 3.08 is the area, 3.08 equals to k, the diameter is 2.8 squared, so you got k equals to 11 over 28, so L is equal to 11 over 28 d squared. Okay, L equals to 11 over 28 d squared. Okay, so what's the value of d when L equals to 19.5? It's easy, so you just substitute the value of area, value of the area 19.25 into our equation here for the area, so you'll get the value of diameter is equal to 7. Okay, so I have another way of answering example 7 is by using the concept of proportion. Okay, why? Because we have this direct variation, varies directly, so meaning we can use the concept of proportion. So here we have the diameter and the area, the diameter and the area, so 2.8 over 3.08 equals to the d over 19.25. Okay, so that's the concept of proportion. So next you just make it you just find the value of d. Oh sorry, it's the square of its diameter. Okay, the square of its diameter, meaning like this. Okay, so then you calculate the value like this one here to get the answer. The diameter is 7. So you can use either way as long as you show your full working. Okay, so next let's move to joint variation. Okay, joint variation is actually a direct variation where a variable varies as the product. Okay, here as the product of two or more variables. Okay, so here I have two direct variations. I have y varies directly as x to the power of m and y varies directly as z to the power of n. So hence the joint variation is y varies directly as x power of m times z power of n, so that we can write y equals to k times x power of m times z power of n. Okay, so it's just a combination, it's just a joint of two direct variation. Okay, so how do you find the k? So just bring everything other than k to the other side, so you get k equals to y k equals to y over x power of m times z power of n. Okay, so how do we see this, the joint variation? Okay, the joint variation, we say it as y varies jointly. Okay, so here y varies jointly as x power of m and z power of n. Okay, so here's for number 4, I have another example. You can have a look at another example there. It's just the same thing, I just use different variables so that you can see how it works. So here is the y varies jointly as x and z, can be read as y varies directly as x and z, y varies jointly as x and z, as what I said just now. Another one is y is jointly proportional to x and z. Okay, is jointly proportional to x and z, jointly proportional. Okay, so nothing much, so that's all for now. Thank you.